All right, we're working with lesson V5, which deals with measures of position. And the first one we'd like to talk about is quartiles. Calculate the quartiles of a range of data sets. To find quartiles, the first thing you're going to do is to arrange the values in order. So we've got 6.6, 6.4, 13.5, so let's see, 28.9, 43.6, 52.1, 79.5, and 99.2. Okay, there's 7 values here. 1, 2, 3, 4, 5, 6, 7, 8 values. So the middle value, Q2, is halfway between these two. Q3 is the middle of these 4, and Q1 is the middle of those two. Okay, so Q1 would be 6.6 plus 13.5 divided by 2, which is 10.05. The next one, Q2, would be 28.9 plus 43.6 divided by 2 is 36.25. And then the last one, 52.1 plus 79.5 divided by 2 is 65.8. So those are Q1, Q2, and Q3. Q0 and Q4 are, of course, the smallest and the largest values. Next one. Let's see, what are we missing? Interquartile range. So the interquartile range is between the second and the fourth, the first and the third quartiles. So let's get the problem written down here. Smallest value is 8.1, 8.3, 15.1, 28.8, 42.6, 69.9, and 89. Oops. 75.4 and 89.7. 1, 2, 3, 4, 5, 6, 7, 8 values. So here would be Q2. We don't care about that. We only care about Q1 and Q3. Q1 is, where's my calculator? Must have closed it out. All right, Q1 is 8.3 plus 15.1 divided by 2. Now, if there would be an odd number of values, it'd just be that middlemost value. So this is 11.7. Q3 is halfway between those two. 69.9 plus 75.4 divided by 2 is 72.65. So if we subtract those two, 72.65 minus 11.7, we get 60.95. That's the interquartile range. Next one. Let's see, what do we have left here? Calculate percentiles of data sets. Okay, let's look at this first one. This data table is in order, which helps you calculate percentiles. The 27th percentile, well, there's 1, 2, 3, 4. There's 16 different values. I'm going to get there are 16 different values times 0.27. 16 times 0.27. So we are looking for the fourth, the one after the fourth value. So it's more than 4 values. 1, 2, 3, 4. The one after that is 43. Let's look at the next one. Okay. Calculate the 17th percentile. Well, there's 16 things again. So 16 times 0.17 is 2.7, or the one after the second one, 1, 2. The one after that is the third one, 18.3. So that's how you find percentiles of data sets. Oops. I'm going to make sure that's all we have in this one. Yep, it is. All right, next one. Calculate z-scores. Oh, let's match box and whisker plots, though that's pretty easy to do. In order to find the box and whisker plot, what you need to do is to find the values for the data set and then see which one matches that data. Okay, let's see here. So in this case, we've got 25 values. You know what would be the easiest to do? Would be to just copy these into Excel and use Excel to find our values. 40, 43, 93, 82, 47, 99, 56, 45, 53, 81, 40, 98, 98, 70, 66, 99, 49, 86, 49, 64, 58, 89, 62, 41, 45. All right, so the first one we want is the minimum. So we write equals minimum of these numbers. And the smallest number is 40. Then we want Q1. So equals quartile and we want the quartiles of this, and the quartile that we want is the first quartile, which is 47. Q2, so that's the equals quartile, and we want the second quartile, and then we want Q3, which is the third quartile of these numbers. And then we want Q4, or the maximum, equals maximum of these values. And we get 99. So if you notice, those are the values in this chart, and so this data set matches that chart. Next one. calculate z-score, talking about 104.2, subtract the average, 78.2, and divide that by the standard deviation, 4.6. So on our calculator, we would have 104.2 subtract 78.2 over the standard deviation, 4.6, and we get 5.7, and it is above the mean because 104 is higher than 78. Last thing we have to do is solve normal distribution problems, and that's easily accomplished if you use your calculator. And we're going to do mode and distributions, which is number 3. Notice I had to go arrow down to get to distributions. All right, let's look at this first one. It's always good to draw a picture, of the problem that you're dealing with. In a normal distribution, what area is to the left of z equals 0.8? So you draw your normal curve. To the left of z is 0.8. 0.8 is above the mean because the mean is here at 0. To the left of that is in this section over here. Now, I always like to estimate how much of the curve that is. That looks to be more than 50%. So I'm going to say that's about, 70%. Now we use our calculator, and it's a normal cumulative distribution, not a point distribution, but a cumulative distribution. What's the lower limit? Well, it's as far down as you can get. So let's say negative 1,000, because you can't get much lower than negative 1,000. The upper limit is here at 0.8, so 0.8. The standard deviation on a normal curve is 1, and the mean on a normal curve is 0. And when we calculate it, we get 7.788. Let's look at number 2. Same kind of a thing, find the normal distribution. How about number 29 miles? So let's get our standard normal curve here. Okay, standard normal curve, mean is 24. Standard deviation is 10.5. More than that, so that'd be 34, and 10.5 less than 24 would be 13.5, somewhere around there. Okay, so we want to know what percent are between the values of 26, 26, which is here, and 29, which is here. We want to know what percent that is first, and then once we find that percent, we're going to multiply that by 44 cars, 44 tow jobs, to find out how many that would be between 26 and 29. I'm going to say this percent is about, 10%. It's not very much, I can tell you that. Let's use our calculator. And we're doing mode, distributions again, number 3, and it's a normal cumulative distribution. We're starting at 26, and we're going up to 29. This time, the standard deviation is 10.52487451, and the average is 24. Our PDF is the 10% that I said it was, and then we're going to multiply that. Let's say ANS equals lower limit, upper limit. Okay, 10.7. I gotta clear this, huh? Mode 1. 0.107 times 44 gives us about 5 if you round it to the nearest car. Let's see. Number 5, this looks like a good one to do. Oh, we did to the left, didn't we? Let's do to the right here. Let's do this one. To the right of z equals 2. So we've got our normal distribution. We're over here 2 standard deviations, and we want to be what area is going to be to the right of that. So we get out our calculator. We're doing a mode distribution again. Go arrow down, number 3. And it's cumulative, so number 2. The lower limit is 2 standard deviations. The upper limit is 1,000 standard deviations, just as long as it's a big enough number. A standard deviation is 1, and the mean is 0. And so we get 0.22, or about 0.023 is our area to the right of that. We've got an area between 2 things. We did that already. I guess that would be how you solve these problems. So this is lesson 5.5.